Hello, my name is Alexandra Doerschel, a board-certified nurse practitioner. Today, I would like to answer the question of, will the COVID-19 mRNA vaccine change my DNA? The answer to that question is no. The COVID vaccine will not alter your DNA. There's a lot of misinformation going around regarding the COVID vaccine. So today I am going to explain how the mRNA vaccine works and why it will not alter your DNA. We all know that vaccines are made to protect us. And traditionally, vaccines were made with dead or weakened germs that were injected into our body to help trigger an immune response. With the mRNA vaccine, what scientists did is, instead of injecting our body with a dead or weakened germ, they injected our body with the instruction of how to build that protein you would find on a dead or weakened germ. It provided our body with the instruction on how to build this protein so that it can trigger an immune response in our body. Let us start from the beginning. Our double-stranded DNA. Our DNA lives in the nucleus and it doesn't leave there. It doesn't ever cross to outside of the cell. It just stays in the nucleus. Now, when our body sends a signal that we're missing a protein, let's say protein to build muscle or protein to build something in the eye, our DNA contains the code to create that protein. It contains the code, but it needs an mRNA to be able to do this, because the proteins are created outside of the cell, outside of the nucleus. And so what it does is it copies the code for that specific protein into an mRNA. The mRNA leaves the nucleus and it goes into the cytoplasm where a ribosome lives. And the ribosome then reads the code from the mRNA and it translates it and creates protein. So we have the DNA in the nucleus. It copies itself into mRNA. It copies a portion of itself into an mRNA. The mRNA leaves the nucleus, goes into the cell and the cytoplasm, into a ribosome, and the ribosome is what then builds the protein that your body needs for your muscle or for your eye or for your hair. So that mRNA doesn't go back into the nucleus. It cannot go back into the nucleus. The mRNA instructions are timed for self-destruction. It's like a Snapchat. It's like a Snapchat. Once it's read, it's gone. And it has a time frame for that. What the scientists have done with this vaccine is they've taken a portion of the virus that codes for the spike proteins that triggers the immune response in our body. So they take that portion, that code, they create this vaccine with it, and they inject it in our body. So they inject us with that code, that message. When our body reads this message, it starts creating the proteins that the virus has on itself, as if we got infected with the virus, but we didn't. What happens is our own body creates that protein. It reads the code, it reads that text message, it reads the recipe for this protein so that our body can fake the virus in our system. And once we start creating this protein, once our body starts creating this protein, our body triggers, or the protein triggers an immune response. Our body thinks, oh, there is this virus in my body. I need to fight it. I need to create antibodies against it. So that mRNA, once the protein gets created, like I said before, it self-destruct. It dies, it disintegrates, it degrades. It doesn't stay in our body. It cannot go into our nucleus. There's so many, there's a very complex mechanism that would need to happen for it to go into our DNA, and it just can't, because it's missing different carriers to go into our nucleus. It just doesn't happen. So no, the answer is the mRNA vaccine cannot interact with our DNA. It cannot get attached to our DNA. It's just, the science isn't there. Well, thank you so much for watching, and I hope that you found this information informative. And as always, if you like this video, please give it a thumbs up, click on that bell, and if you need some more health-related information, please visit www.telakaihealth.com, where you can read up on other conditions that may be affecting you. Thank you, and I will see you next time.